Hey there, Seahawks, it's Miss Adams, and in this video, we're going to talk about designing experiments. Alright, any decision made using the results of a statistical study are only as good as the process used to obtain the data. When the process is flawed, the resulting decision is questionable. Alright, an experiment versus an observational study. Well, we already talked about an observational study a little bit. In an observational study, a researcher observes and measures characteristics of interest of part of a population, but does not change existing conditions. In an experiment, a researcher deliberately applies a treatment before observing the response. A treatment is applied to part of a population, called a treatment group, and the responses are observed. Another part of the population may be used as a control group in which no treatment is applied. Experimental units are the subjects in the treatment and control group. A placebo is when subjects in the control group are given a placebo, which is a harmless fake treatment that is made to look like the real treatment. So sometimes it'll just be a sugar pill or like a pretend shot, something that looks like the real thing, but you're not actually getting anything. The placebo effect occurs when subjects react favorably to a placebo when in fact the subject has been given a fake treatment. So when the subject actually starts improving, even though they weren't getting the real treatment, they were getting just a placebo. Blinding is a technique where the subjects do not know whether they receive a treatment or a placebo, and it's used to minimize the placebo effect. If you're going to use the placebo, you definitely want to make sure that you have some form of blinding. A double blind is when neither the experimenter nor the subjects know if the subjects are receiving a treatment or a placebo. All right, so only the person in charge of analyzing the data would know who's getting what. Confounding variable occurs when an experimenter can't tell the difference between the effects of the different factors on the variable. So kind of something in the background that you can't tell, did this happen because of this, or did it happen because of something else? Blocks are groups of subjects with similar characteristics. Randomization is a process of randomly assigning subjects to different treatment groups. Okay, it's very important to have randomization when you're designing an experiment. Replication is the repetition of an experiment under the same or similar conditions. Okay, you also want to repeat it many, many times. Observational study or experiment. Researchers demonstrated in people at risk for increased cardiovascular disease that 2,000 milligrams per day of acetyl L-carnitine over a 24-week period lowered blood pressure and improved insulin resistance. Okay, so we don't have a whole lot of details, but we are assuming that this was done through an experiment and they were assigned to treatments. Typically, when we're working with people, we really don't give a real placebo. We usually just keep them on their current medication if they're needing that medication because they're at risk of heart disease. Then you wouldn't want to just give them, oh, we're going to take you off that and give you nothing. So they're assigned to a treatment, we're assuming. But it probably was just stay on your regular treatment or add this to it. Number 2, to study the effect of music on driving habit, 8 drivers, 4 male and 4 females, drove 500 miles while listening to different genres of music. Okay, so this could depend. Again, we don't have a lot of information. It would be an experiment if the drivers were assigned to a specific genre to listen to. If they just made note of what genre of music they were listening to and how they drove, then it would be an observational study. But I think this would probably be set up as an experiment. To study predator-prey relationship in the Bering Sea, researchers looked at the feeding behaviors of 3 species: black-legged kittiwaks, thick-billed murreys, and northern fur seals. Okay, so they just looked at their feeding behaviors. This is an observational study. They didn't force the different species to have different treatments. All right, the different types of designs for an experiment. We can have a completely randomized design where subjects are assigned to different treatment groups through random selection. All right, so we're going to do an example. You have 100 individuals with high cholesterol, and you want to design an experiment to test the effectiveness of eating a bowl of Cheerios every morning and lowering cholesterol levels. All right, so we're going to start with 100 individuals with high cholesterol, and we're going to break them up into 2 groups of 50 so that we want to try to have it as evenly separated as possible. It doesn't always have to be, but that would be ideal. So 50 of them are going to eat Cheerios, 50 of them we're going to say are going to skip breakfast. And then we're going to compare the results. So that group skipping breakfast would be my control group. All right, and then right here, when I started with my 100 and I broke them off, I have to make sure that I randomly assign those 100 people to their treatment groups. And so I'm going to put a star there, and then I'm going to explain how I'm doing that. Okay, so I'm going to randomly assign to groups by putting all the names of the 100 subjects in a bag. I'm going to shake the bag. That makes it random. Now it's randomizing because you're shaking the bag. The first 50 selected get Cheerios. The remaining 50 skip breakfast. A randomized block design. The experimenter divides the subjects with similar characteristics into blocks, and then within each block randomly assigns subjects to treatment groups. Okay, so this is similar to like a stratified random sample, but that's for random sampling, and this is for experiments. Okay, so they're kind of similar where you have these different groups. All right, so in a randomized block design, we want to do this example. Miss Sparrow has 2 versions of her midterm exam for pre-calculus. She wants to determine if there are any significant difference in the difficulty of the 2 versions. She has about 152 students in 4 sections of pre-calc and wants to keep the sections together to minimize confounding variables. All right, so we're going to start with 152 pre-calc students, and we know she has 4 sections, so we're going to break that off into period 1, period 2, period 3, and period 4. If we're going to assume that they're evenly distributed, they may not be. We're going to go with that because we don't have the details of that. So we're going to say that means 152 divided by 4 would give me 38. So there's 38 in each class. And I didn't do any random assignment there, just yet. Now, in period 1, I'm going to randomly assign half of them to get version A exam, half of them to get version B exam. Okay, so that would be 19 and 19. And that is where I'm using my randomization. I'm going to randomly assign period 1 students to get either version A or version B. Then I'm going to do the same thing for each period. Notice I didn't write version A exam. I just put A and B to kind of simplify things. And then I would compare results. All right, I do want to mention how I randomized. Okay, so I'm going to put a little side note. I put the names of all the first period students in a bag. I shake the bag. The first 19 get exam A. The remaining get version B. Repeat this process for the other class periods. All right, and then a matched pairs design is when subjects are paired up according to a similarity. One subject in each pair is randomly selected to receive one treatment, while the other subject receives a different treatment. For instance, 2 subjects may be paired up because of their age, geographical location, or a particular physical characteristic. Also, each subject could get both treatments, but the order is random. Okay, so sometimes one subject gets both treatments just in a different order to compare results. And sometimes, a lot of times, the matched pairs design will be done on twins that have the same genetic makeup, but one gets one treatment, one gets another. But they have to have some reason to be paired. We're not going to do an example for that one, but we'll do some in class. All right, go Seahawks!